Hello everyone, welcome to the Technogate. So today I will discuss the applications of divide and conquer. So what is the first application here? Maximum and minimum in the given array. Okay, how to find the maximum and minimum in the given array. So first of all we will discuss without divide and conquer. After that we will discuss with the divide and conquer and differentiate both of them, which one gives best time, which one give best space. Okay, so first of all we will take without divide and conquer. Okay, so what is the input here? So input is an array of n elements, an array of n elements here. And what is the output here? So output is find maximum and minimum. Okay, so let's take an example here. So taking one example here, so let's see this. So suppose that here 10, 20, 30, 1, 2, 3, 11, 21, 31 here. So this is the array here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the maximum element here? Maximum is what here? 31 here. 31 here. And minimum element is 1 year. So your output is what? Minimum 1 year, maximum 31 year. Okay, so first of all we will discuss without a divide and conquer. Without a divide and conquer, and after that we will discuss with divide and conquer. Okay, so without a divide and conquer, what is the approach here? So without a divide and conquer. Okay, so what is the approach here? So approach is what? Initially assume first element is a maximum here. First element is a maximum. How much is 10 here? And first element is a minimum here. Minimum is 10 here. First is a maximum, first is the minimum here. So let's see this one. So compare 20 with 30 and 10 and 10, max and min both. So 20 greater than maximum, yes, update maximum. No minimum updation here. 30 greater than maximum, yes, 30 will update here. 1 greater than maximum, no. 1 less than minimum, yes. 2 less than 30, no. 2 greater than 30, no. 2 less than 1, no. 3 greater than 30, no. 3 less than 1, no. 11 greater than 30, no. 11 less than 1, no. 21 greater than 30, no. 21 less than 1, no. 31 greater than 30, yes. Update it. So this is a maximum here, this is a minimum. So this is the approach. So what is the approach here? Initially assume first element is the maximum and first is the minimum here, and update after that every maximum, every minimum here. Okay, so let's take the example here and see the code of the without divide and conquer and discuss with the time complexity in the worst case, best case and average case. Okay, so let's see this one. So first one is without a divide and conquer. Without divide and conquer here. Okay, let's see this. So here take the array here. So here 10, 20, 30, 1, 2, 3, 11, 21, 31 here. Okay, see this one. So here divide maximum here. So take a function here, strat maxmin. This is a function. Okay, you take any function here, and a will pass, array name pass, and n will pass here. So this is the array, and number of elements are how much there are? 1, 2, 3, 4, 5, 6, 7, 8, 9 here. Okay, this one here. So strat max means a function here. So initially, what is the concept here? Assume maximum and minimum is the first element. What is the first element here? 10 here. This is 10 here. This is 10 here. Okay. So max equals to mean equals to a of 1 year. Initially, first element is the maximum element, first element is the minimum element here. First, okay. Now, compare these max and minimum with other elements and take the updation. Either maximum will be updated or either minimum will be updated. No issue here. Okay. So, let's check here. So, for I equals to 2 here, starting with 2 here, I less than equals to n, I plus plus. Okay, this one clear. Now if a of I greater than maximum, if a of I greater than maximum, then update maximum here. So maximum is what here? Maximum is what? A of I. Maximum is what? A of I. Okay, maximum is a of I here. Clear? Else, if this condition is false, else if a of I is less than minimum, if a of I less than minimum, then who will update? Minimum will be update here. So minimum is a of I. Minimum is a of I here. Okay, and after this one, okay, this one after return maximum and minimum element here. Okay, after for loop, so return maximum and minimum element here. Okay, so return maximum comma minimum here and close the loop here. So this one here closed here, this one is closed here, this one closed. Okay, so this is the without divide and conquer. Let's check this is working or not working here. So taking this one. So maximum minimum is first element here. Now I is 2 here. So a of I, a of 2, 20 greater than maximum, yes. So maximum will update here. So this becomes 20 here. This becomes 20 here. Now 30 greater than maximum, yes. So maximum will a of I means 30 here. Clear here. Now 1 greater than maximum, no. Now yeah, else if 1 less than minimum, yes. So update minimum here 1 here. Okay. 2. Now 2 greater than maximum, no. 2 less than minimum, because minimum now 1 year. So both are false here. No updation in the maximum, no updation in the minimum here. 3 greater than maximum, no. 3 less than minimum, no, because maximum is 30 now and minimum is 1 now. 3 greater than maximum, no. 3 less than minimum, no. 11 greater than maximum, no. 11 less than minimum, no. 21 greater than maximum, no. 21 less than minimum, no. 31 greater than maximum, yes. 31 greater than maximum, yes. So maximum is what? 31 and minimum is 1. These are desired output here. This is the desired output here. Clear here? So now take best case, worst case and average case time complexity. What is the worst case time complexity? What is the best case time complexity? And what is the average case time complexity here? So let's check here. Okay. So here let Tn be the number of comparisons. Okay, Tn be the number of comparisons for n elements. Now check first best case. First one is the best case here. Okay. So best case will arise when the input is already shorted. So always remember, you can say about the best case and worst case when the input is given. If input is not given, then always consider the average case. Okay. So best case will appear here when the input is already shorted here. Where the input is already shorted here. So let's see this one. Like 5, 6, 7 and 8 here. Already shorted here. So 1, 2, 3 and 4 here. So maximum is what year? Initially maximum is 5 year and minimum is 5 year. Initially maximum is 5 and minimum is 5 year. Okay, so check this one here. So I is 2, 6 greater than maximum, 6 greater than maximum because maximum is 5 year. So update maximum here, how much it is? 6. So control note goes to the else part here. Now 7 greater than 6 year, yes 7 year. 8 greater than 7, yes 8 year. This one. So only this part will execute only. Only one comparison is there. Only one comparison there, not the second comparison here. So for every element, how many comparison? Only one comparison, this one only. So how many element here? There are n minus 1 element are there. So in the best case, for every element there are one comparison. So how many element there are? N minus 1 into 1. So how many comparisons in the best case? N minus 1 comparisons in the best case. And best case will arrive when the input is already shorted. When the input is already shorted, so only one comparison is there. So there are n minus 1 element and then n minus 1 comparisons. So what is the best case time complexity? Higher order term is n. So omega of n is the best case. So best case, we are talking about the best case. So we use the notation omega here. We use the notation omega here. Okay. Now check the worst case time complexity. Let's check the worst case. Okay. Second is the worst case time complexity. Okay, so worst case will arise when the input is already reversely shorted. When the input is reversely shorted, suppose that 10, 9, 8, 7, 6 and 5 here. The input is already reversely shorted here. So let's check here. So maximum is what here? 10 here. Minimum is what? 10 here. Initially first element is the maximum, first element is the minimum here. Here now check. 9 greater than maximum? No. Condition false, then goes to the else part here. So 9 less than minimum, yes, because minimum is 10 here, 9 this one. Now 8 greater than maximum? No. 8 less than minimum? Yes. 7 greater than maximum? No. 7 less than minimum? Yes. 6 greater than maximum? No. 6 less than minimum? Yes. 5 greater than maximum? No. So one comparison here for every element. One comparison here, 1 year. There are two comparison for every element here. Okay. This is 5. Okay. So number of comparison is what in the worst case? So number of comparisons. What will here? So every element there are two comparisons. 1 and 2. So n minus 1. How many there are? 2 into n minus 1. So 2 into n minus 1 comparison. For every element there are two elements are there. And how many elements are there? Are n minus 1. So 2n minus 2 here. So what is the big O of n here? Because we are talking about the worst case. So big O of n time is required. Okay. And number of comparison are 2n minus 2 here. Okay. 2n minus 2 here. Now we will discuss the average case. Okay. So in the worst case, number of comparisons are very important here, 2n minus 2. In the best case, n minus 1 here. And now discuss was the average case. Average case. Discuss with the average case. So average case is what? Is a division of worst case and best case. So average case complexity is n minus 1 best case plus 2n minus 2 worst case divided by the 2 here. So what will happen here? 3n minus 3 by 2 here. So what will happen here? 3 is common, so 3 by 2 n minus 1. So what will have 1.5 n minus 1. So number of comparison in the average case is 1.5 n minus 1. Number of comparisons is 1.5 n minus 1 here. So what is the complexity in average case? Theta of n. So complexity is same in every cases, three cases, worst case, best case and average case, but here number of comparisons differ. In best case n minus 1, in worst case 2n minus 2 here, and in average case 1.5 n minus 1 here. Theta of n comparisons are there. Theta of n comparisons are there. So these are the without divide and conquer. Okay, these one are the without divide and conquer. Now in the next lecture we will discuss about the with divide and conquer. Okay, and we conclude that which one is better. Which one is better, either divide and conquer or without divide and conquer. Okay, so we will discuss about the with divide and conquer in the next upcoming lecture. Okay, thank you everyone.